in this section, we're going to start taking a look at vectors. All right. And vectors are one of the more important topics for those of you that are going to be studying engineering and physics and upper level sorts of calculus. We use vectors a lot. And so in this lesson, we're going to go ahead and try to define vectors and a lot of terminology associated with vectors. We're going to start to write vectors in two different forms, something called a component form and as a linear combination. We're going to be able to graph vectors, and then we're also going to be able to perform a bunch of operations on vectors as well. So let's define what a vector is. A vector in a plane has magnitude and direction. Okay, so think about throwing a baseball. There's some sort of magnitude, which would be the velocity, and the direction with which you would throw the baseball. Okay, or think of a gust of wind or something like that. Okay, that would be real life fundamental applications. Vectors are always bold lowercase letters, okay? At least for what we're going to do in our class. If a vector has no magnitude, it's called a zero vector, and it's bold zero, okay? And two vectors are equal if they have the same direction and the same magnitude. And one of the things that we want to make sure of is that we can compute the magnitude. And what you'll see is that the magnitude is actually pretty close to the distance formula, all right? And so that's exactly what we're going to do is we're going to actually use the distance formula to be able to write or to be able to find the magnitude of a vector, right? Magnitude is the same thing as the distance of the vector from the initial point to the terminal point, okay? So if you see in this diagram, the initial point and then it goes in the direction of the terminal point, okay? So vectors are always straight lines until you get to calculus 3 where we have vector value functions. Right. Component form is going to be written so that we have a vector so that its initial point is at the origin. And the component form of vector with initial point p sub 1 and p sub 2 and terminal point q1 and q2 is going to be found by q2 minus or q1 minus p1. So I just subtract the x coordinates and then I subtract the y coordinates. Okay, and that's how it's going to. That's where we're going to go through and being able to um, find what the component form of this is. So one of the very first things we have to do is we just have to be able to graph vectors and then to be able to just plot them on a graph. Okay, so let's say we have this vector with it, we have an initial point -3, -5, and a terminal point 5, 1. And we want to construct the vector. We want to find the magnitude of the vector, and then we're going to find the component form and graph it and plot it on the graph. Okay, so this is actually a really easy problem. So here's our Cartesian plane. We have the point -3, -5. Okay, so this is our initial point. Okay? And then the point 5, 1 is going to be the terminal point. Okay, so this is what our vector would look like. Okay, now notice it doesn't pass through the line or the 2 points. Okay, it just touches those 2 points. And so that's what the vector would look like construction. Okay, if we want to find the magnitude of the vector, then we're just going to go ahead and use this formula. Okay, so I'm going to call this, let's just call it the magnitude of u. Okay, and that's going to be equal to the square root. We're going to take 5 minus a minus 3. Okay, so just like the distance formula. And then 1 minus a minus 5 and square it. And so we're going to end up with 8 squared plus 4 squared. Okay, or 6 squared, excuse me. I thought that was a 4. Couldn't read my writing. That's probably not good. All right, so we get 8 square plus 6 square. All right, this is going to work out really nicely. This is going to be the square root of 64 plus 36, or the square root of 100, or 10. Okay, so the magnitude of this vector is 10. Just as a side note, really quickly, whenever I draw vectors, because I can't differentiate between bold and not bolded letters, I might do this. I might put a caret over top of the letter that I'm using. So if I ever see a vector that I can't put bold, like my U, I might just do a U with a caret over top of it. Okay. Now finally, we want to find the component form. Okay, so to find the component form of U, I'm going to subtract the the x coordinates. So terminal minus initial, 5 minus a minus 3, comma, 1 minus a minus 5. And so that means that the component form of our vector u is going to be equal to 8 comma 6. Okay? And so what that would mean is I'd have to plot the point 8, 6. So we already have 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6. And so in standard position, okay, and I know I didn't draw that too well, forgive me, or maybe just fast forward a second or two. All right. And this is about what our vector should look like. Okay. Now, these two vectors are equal. Okay. So this vector and this vector are equal because they have the same direction and they have the same magnitude. Okay. If you don't believe me, then just go ahead and find the magnitude. Didn't need to erase that. Um, that kind of messes everything up, but anyway. But you could remember that this was from the origin, so just pretend it's from the origin, okay? All right, so in our next video, we're going to do a few more of these, but I just wanted to give you an introduction as to what these vectors are. Again, they both have direction and magnitude. This is how we would find the magnitude. This is how we put it into component form, and the direction is just basically where the terminal point is for these sort of things.